we actually need during these presentations to keep people knowing about the product and the technologies that we carry in the DTX series. As Mike explained, the DTX is such a beautiful product. It's a fantastic product. It helps a lot on the field. It helps to generate the happy result, the green result, and it helps to identify that there's a fault on the cable. Now, the beautiful part of the tester that it's one of the very simple operating testers that you can find in the market today. All what you need to do is make sure that you configure it with the proper configuration for the site. You need, let's say, Cat6 cable. Put the basic configuration in that. And once you are at each port of the patch code, you need to press the white button, the test button, and the machine will do everything for you. You don't need to think about any other parameter. With just a simple press on test, it takes up to 10 seconds, the fastest test that you can have, and within 10 seconds you will be able to know whether your cabling is okay or the link that you have installed and you're doing the test is okay or not. And happily we got a green flag, which is a pass flag, and this is what we normally need to see in our links. Imagine you have 10,000 links on a project and you get 10,000 pass, you'll be relieved. You'll deliver the test result to the consultant, you get it approved, you get your money back, and then you quit the project. But that's not always the good story that we face on site. Sometimes we get 100% pass, but some other times we might get different topics or different flags on the machine. And that these flags can vary from green to yellow to red. How many people often see red flags in your machine or when you do the testings? He does. Oh my God. How often do you see it on the site? It's very regular. Very often to see flags on the network when you do the test. So the green is always a happy flag. It's a pass. You continue, you move to the second one. The second pass, which is highlighted in yellow, it's called start pass. Start pass means that we are just at the margin of the standard. So if the standard says, yes, I'm okay with 3 dB, my limit is 3 dB, and you are at 3 dB or 2.9 or 3.1, the standard might say, okay, you might pass, but you are at the limit. Some cabling vendors might not accept a start pass results. Or if you have a big project, 10,000 outlets, if you come with a couple of outlets with start pass, it might be accepted. But if you come with 10,000 start pass, then there's a flag. There's something wrong. Either the equipment, you have something wrong with the equipment, not calibrated properly, or the cabling system you installed is not properly installed, or there's a problem in the cable, so it has to be re-investigated. When you have a red flag, it means a disaster. Not a really disaster, but there's a failure, and we have to investigate the source and the reason of the failure. So always, let's try to keep our finger crossed to get the green flag and to get the pass result. Now, what if, after doing the test, we get the red flag, a failure? What the first thing we do? From you guys, what are the normal practices you do in the field?
Check the termination again.
Check what is the failure.
Check what is the failure, yes. So we need to first try to locate the failure. Then,
check the termination. Check the termination again.
Check the termination is a later on procedure, but first, once we get the fail, we need to know where are we failing. So we need to do diagnostics. We need to start trying to find out where the cause of the problem, where the root cause. And whenever we go into a higher frequency in the cabling system, the more stringent, the more difficult is the results and the parameter would be. Testing Cat5 is totally different than testing Cat6a or testing even Cat7 or 7a. So limits are totally different and everything comes really challenging. So next and return loss are serious measurements we need to look into the testing when we look at. And it's not always a green flag we might get a yellow flag or a red flag for many, many reasons, and that we need to find out what is the problem. We need to troubleshoot all the failed link in the right way, in an efficient way, to figure out the cause of this problem, and to reduce the time that we need to fix that link. You might see a red flag, and if you don't know what's happening, the first thing what you do, you re-terminate the connection. You come and do the test, again failing. And you do another re-termination, and another re-termination. And what's happening in that point, that point of time? You're reducing your length of cable, you don't have enough more slacks, you're spending more time on the termination, and you're retesting, and probably the connector is good, the termination is good, but the problem is somewhere else. The problem probably is inside the cable. So, all these things has to be properly troubleshooted and managed at the time we get a red flag. The key things we need to really monitor when we do the tests are the near-end crosstalk and the return loss. We're going to see them into a few slides. But normally when we do the test, and if it fails, there's another test the machine will do, and will generate internal diagnostics to identify what's happening in the equipment. So it's not only a fail that, okay, this thing fails. No, the machine will retest again and see what's happening inside the cabling system to help you find your fault. And then when we have a fail, as Mike was saying in the beginning of the presentations today, there is a fault info button, and that button, when we click on it, it will tell us what is the expected cause of a problem here. One of the problems can be here. We're testing Cat6, but the testing of the cable shows that the performance is very bad on the cable. The machine suspects that the cable might be a lower grade than Cat6. So you might need to investigate, did I install the right cable here or not? Another thing, it will tell, on another instance, it will tell you there's a wire map failure, there's a problem with the wire map. What are the distance? 1 feet. Just too short. So there's something wrong in the termination, there's something wrong we have in the cabling system. So if you properly use the fault information, the fault key, it can give you an immediate alert, an immediate guidance where to find the fault. How many people do use really the fault? Do you use it when you get faults? You use it? Good. People who does not use it, please try to use it. Try to see what it can show you. There's additional features in the machine. It's not only about the fault.
Can you go back, please, if you don't mind? Yeah, in this one you're saying the wire map, right? It
Yeah.
can be a wire map failure.
Yeah.
If it is a wire map failure, then the first one, if you go further back, you
Yeah,
see that should, this should still fail.
This is not
Showing fail.
This does not mean this. This is just a compilation of pictures.
Okay.
A compilation of pictures. So it's
okay.
the picture
All right.
here does not mean
Okay.
this, does not
All
mean
right.
that. We're just trying to show that you might get a failure, you need to investigate what is it. Then if you, at the point of failure, if you press the fault, you will see something. That something can vary depend on the type of the fault. Okay? Then, if we look at the fail, if we need to investigate more within the fail, there are other features within the DTX equipment that comes at the end, and they help us a lot whenever we get a failure. The HDT features, which we'll get to it. So, what is the HDT feature? The HDT will actually, what does the equipment do? The equipment does a complete frequency analysis on the cable in the beginning. If there's a failure, it will redo another type of frequency analysis over the whole range that we're testing. If we're testing Cat6, it will do a 250 megahertz complete analysis. If we're testing 6A, another 500 megahertz. So these are the two tests normally that are happening if we have a fail. If we have a pass, only the first test will happen. So we'll do a complete frequency domain, analysis, and if we have a problem, this is where we need to identify and we need to look at the cause of the problem. So we have two types of analysis. We have the high definition time domain crosstalk. So if I have a next problem in my equipment, if I have a next failure, the first thing I have to do is to check the HDDTX to find out what is the source of my problem. If I have a return loss or reflectometer, then I have to use the HDDTR to find out the reason. Now, to get things a little bit clearer, first, who is using these features when you have failure? Please raise your hands if you're using it. You're not using it in your failures? This is a serious thing that you need to consider when you're doing your measurement and testing on failure links. It really can pinpoint out to you what is happening on your link. So, in terms of next, what is next?
Crosstalk.
It's a crosstalk. What is crosstalk? It is a noise. It is a noise between two pairs at a point of a link, either at the source of the link or at the destination of the link, or either at the main unit or at the remote unit. So next is a noise. And what is the cause of next? Why we have next? Mainly next, we can get it in improper termination, excessive interest of the cable, bad cable, split pairs. So we can have really so many causes to tell why next is there. So if we have a next failure, it is mostly a personal behavior at the site that we need to rectify. Return loss is what? Return loss, and some people like to say it's an insertion loss. It's a return of a signal that looks like a ghost. I send a message and I reread it again. Why? How? So this is kind of noise that can happen when we have different impedance in the cable, different types of cable. If I mix a cable of 100 ohms with a cable of 120 ohms, which can happen, or 100 ohm and 105 ohms, a little fluctuation in the impedance of the cable, that can cause really the return loss. Also, bad connectors, untwist of the cable can cause also the return loss. So, whether I have a next or return loss failure, there's a reason to know where is the failure. And the reasons to know is by using the high definition time domain crosstalk, the HD